Hello again, everybody, and welcome to this, the fourth in a series of short videos I'm doing to promote a radical yet logical alternative hypothesis to the standard model of both quantum physics and cosmology. In the first video I did, it was a general overview of this hypothesis, and in the second one I concentrated on the atom. In the third one I did light, and I'll leave a link to those down in this, when I sign off this video. Anyway, in this video tonight, what I'd like to do is to concentrate on gravity. Now, there's different theories of gravity that people have come up with, but nobody seems to have been able to grasp exactly what it is. And in my hypothesis, I propose that there are in fact two forces of gravity. Now, it's said in the standard model, and according to Einstein, that gravity is not a force. But I disagree with that. I say it is a force, and I say it's got nothing whatsoever to do with the curvature of space or anything like that. It's much more logical and straightforward. And I propose that there are two forces of gravity, and linked to that there is a conception in physics, in the physics community, that there ought to be monopoles in the universe, monopole particles. Now, they say that these don't exist, but I would like to give a proposition that explains that they do exist. They exist in everything that the universe is composed of. And it comes down to dark energy and dark matter, which are two other things that can't be explained. And I maintain that these are all linked very closely together with gravity. So first and foremost, I'll deal with the monopoles. Now, I believe that everything in the universe is composed of just two incredibly small monopole particles. One is a positively charged monopole particle called a danitron, and the other one is a negatively charged monopole particle called a havitron. I've given them these names for personal reasons, but anyway, getting back to the basics, I maintain that there is a massive imbalance of the negative particles, monopole particles, to what there are of the positive monopole particles. I maintain that the positive particles will only be found in atomic matter, and to be more precise, they will only be found principally in the nucleus of atoms and atomic matter. And the interactions of these particles will account for gravity. The atomic matter, the nucleus, where the positive particles are concentrated, gives rise to the attractive force of gravity between masses of matter. And we know that gravity is proportional to the mass of any matter. So what I propose, and it would be far better if the whole hypothesis could be read. This, and it is published in this little book here called The Two Monopole Particle Universe, and it explains exactly how I think this radical alternative to the standard model works. But if I can narrow it down a bit, I maintain that the whole of the universe, every available space in the universe, is filled with negatively charged monopole particles. This is what I claim is dark matter. And obviously, if you've got like charges, particles all clumped together, they will be trying to repel each other in every direction. So I maintain that throughout the universe there is a negative force of repulsion pushing everything apart. Now, it's not expanding the universe, because I'm convinced that the universe is not expanded. So what you have to consider that is that there will be a static pressure throughout the universe, and Einstein sort of put this down as the cosmological constant. So it's well known that there is a pressure in the universe, and I maintain that that pressure is dark energy, which is the consequence of dark matter particles trying to repel each other in every direction. I maintain that it is this pressure that is holding all the planets and all the matter in the universe in their relative positions. And I maintain that that is one of the forces of gravity, because I believe that gravity consists of an attractive force and a repulsive force. So the way I describe that the atom works is that the nucleus is composed of these two monopole particles, and due to their interactions they combine tightly to form the nucleus. Because there are negative particles in the nucleus, you will have a repulsive force pushing out, and that repulsive force is being met by the repulsive force of what I would consider to be the dark matter cloud. So imagine you've got a negative force coming out from the nucleus, and all surrounding it you've got a negative force pushing against it. But going back to what I said in the beginning, the nucleus is composed of both positively charged monopole particles and negatively charged monopole particles, and their forces of attraction and repulsion extend beyond the physical size of those particles. So in effect you've got them being pushed together, but their forces are carrying on beyond that merger. So you've always got both a repulsive force and an attractive force, and the attractive force of the positive particles are trying to attract the negative cloud, the dark energy cloud, and the negative particles that are contained in the nucleus are repelling those particles. So this would explain why the conventional wisdom of the atom is that you've got a nucleus that has got an excess of positive charge, and it's said that the surrounding that are electrons that are negative, and they cancel each other out. Well, nobody's been able to explain logically why the two don't combine together. And in my model, there is a logical explanation, is because once you've got the nucleus formed with however many positively charged particles there are in that nucleus, which will determine exactly what element it is. So obviously, if you've got a hydrogen atom, you've only got like a small amount of these positive particles in the nucleus. But if you've got something like an iron one, or the higher end of the periodic table, you would have many more of these positive particles in the nucleus. But balancing that, you would have equally more negative particles in there with them. So you've got an interaction between these forces of a push-pull arrangement. And this is where the strong nuclear force comes from, because I would contend that when they're pushed together closely, and bearing in mind you've got this this cloud producing a negative force, which is trying to crush it in the nucleus in tighter, you get a point where you've got these forces forcing in and out, and you will have the boundary of your nucleus, which is the limit of how many positive particles there are in there, and you've got a negative force coming out of it, you've got a positive attractive force trying to pull in, and you reach a point where those forces reach equilibrium, and that will be the boundary of the atom. Now, my idea of gravity is that on a cosmic scale, it works exactly the same. So you could say my version of the atom is quantum gravity, but when you extend it out to the universe, it becomes cosmic gravity. They're all the same thing, it's exactly the same forces. I will maintain that every force in the universe that we know of is basically down to electromagnetism. Now, I will maintain that when you've got a body of matter, such as the Earth or Sun, whatever, the larger the body, the more positive particles are contained in that. So they will exert an attractive force to anything negative, which is the cloud of negatively charged dark matter particles. Because they're so small, we haven't got any way of detecting them. And because they haven't got any nucleus to them, it's just monopole particles, incredibly small. Light doesn't interact with it, so that's why it's referred to as dark. We can't see it, but it's there. We know it's there because there's a pressure there. And the way I describe it is that not only have you got an attraction of matter to matter, because if you've got a small amount of matter and a large amount of matter, the positive particles in that matter, the positive atoms in that matter, positive nuclei in that matter, will be trying to, once you get too close, they will try to combine with the negative particles that are in the larger body of matter. If they're, depends on the distance apart, and we know that gravity is proportional, the strength of gravity is proportional to the distance that bodies are apart. So once they're a certain distance apart, then the dark matter, dark energy pressure is basically keeping them apart, holding them in suspension, if you like. But should anything happen where two bodies of matter get too close together, there's too much of an attraction of to that, the positive sides to that matter to keep them apart. There's not enough negative particles in there pushing them apart. And that's how I believe gravity works. It also explains the missing monopoles, because I contend that everything is made up of monopoles. But if you think about it, because there's such a massive excess of the negatives, wherever you've got a positive particle, it will always be encompassed with the negatives. So in effect, instead of acting like monopoles, they'll act like dipoles, because you've got two opposite charges connecting together. So in all matter, you won't find any separate monopoles. You wouldn't be able to measure any separate monopoles. Certainly, if you're looking down at a nucleus, level of the nucleus. But anything beyond a nucleus will only be negatively charged particles. So there's no way that we can detect that, because everything consists of that. So you've got a universal field, if you like, and anything that we detect it with dipole magnets. It's all a bit hairy-fairy to try and sort of describe it in a short video like this. But if we consider that gravity is a force, but not just one force, two forces, it will make sense of why the calculations that are done, all the mathematics, don't tend to add up, and why it's been a mystery for so long. Because in effect, the physicists are only dealing with half of the forces, so all their equations are way out. I know it sounds weird, but if you think about it logically, this system will work. And like I say, when you read the whole hypothesis, it all starts to make sense, because everything's interlinked, both in the way that matter is formed, which, is referred to as cosmic nucleosynthesis. And it's I can get myself a bit tongue-tied here, sorry about that, but I contend that in the it never came from a big bang all at once. I contend that matter emerges from things like supernova and that sort of thing. The intensity of the forces and heat and everything else in a supernova is such that matter can be formed from that. You can't destroy matter or anything like that. You can only change its form. And I contend that what the universe is made up of is these two particles, but the amount of these particles are constant. They're not destroyed. They're never altered. Whether a planet explodes and they burst apart, those particles stay the same. So therefore, like I say, any positive particle that is around, and depends on what the forces that are at that point, will determine how many of these particles will clump together to form a nucleus. And that would account for the different elements. Now, it's been fairly well recognised that there's a lot of the lighter elements about, and it's proposed that the heavier elements form in stars, which is fair enough. I'm not arguing with that at all. That's fine. But what I think is a misconception is the idea of antimatter. I think that antimatter is any kind of embryonic nucleus. And what I think the situation is that if you've got the smallest atom that we know of is the hydrogen atom, the simplest one. If you've got anything smaller than that, because of the way I propose that the nucleus is made, you can have nuclear matter that has less size than what the hydrogen atom is. But at that point, it is too small to be either to receive or to emit a photon. So therefore, it's pretty invisible to light. It's not matter as we know it. So I think that is what's mistakenly called antimatter. And I would say that that's just an embryonic nucleus, and until it reaches the size of the hydrogen atom, it doesn't become a proper atom. And the criteria for being a recognisable atom is when it is large enough to receive a large enough pulse of energy, or to be able to emit a large enough portion of energy, which we refer to as a photon, the quanta of light. I think I'll leave it there because I'll get myself a bit more tongue-tied if not. If you want to see any more of these videos, could you possibly click the like button and subscribe? It doesn't cost anything. And if you type in the 2 monopole particle universe into YouTube, then those videos should come up, and I'll give a link to them as well. But if you type my name, Tony Norman Marsh, into Google, then details of this little book will come up. Okay? Anyway, best of luck everybody. Thanks for clicking on, and I hope to see you again. Ta-da!